Scatter plots and lines of fit. At the end of this lesson, you should be able to answer how can a linear equation model the relationship between two sets of data. And in order to do this, you need to know what a scatter plot is. It's simply a graph where you're graphing a set of data pairs or a set of ordered pairs. And when you do that, there's a possibility that you'll see one of three types of correlations. Either a positive correlation, which you see on your left, a negative, or no correlation at all. And the relationship with a positive correlation would be as your x variable increases, your y variable also increases. Whereas with a negative correlation, as x increases, y does the opposite, it decreases. In no correlation, there's no obvious pattern between the points, x has no effect on the y variable. In the positive correlation, it's possible to draw what we call a line of best fit. And that's a line that has all the points about an equal distance from that line. Negative correlation would look like this. And notice that with the positive correlation, your line of best fit has a positive slope, and with a negative correlation, there's a negative slope. With no correlation, you are not even able to draw a line of best fit because there's no trend in the data. Now, let's see what type of correlation we think exists between the given data here. In the first one, we're looking at hours of study and test scores. I would say that there's a positive correlation because as the hours of study increase, the test scores seem to be increasing as well. If I were to sketch a line of best fit, it would look something like this. In the second one, it seems to me like the points seem to be dropping from left to right, so I would say that there's a negative correlation. It's definitely not a very strong correlation. The closer your points are to that line of best fit, the stronger the correlation is. So this is a weak negative correlation, but as the hours of TV watched increase, the test scores do seem to be decreasing. So I would say that my line of best fit would look something like this. I have three scenarios on the screen. What type of correlation would you expect there to be between these variables? So what I typically do is I identify my x and my y, and I think, well, as the ages of elementary school students increase, what would happen to their height? Well, that would go up, so this would indicate a positive correlation. In the second, as calories consumed increase, what would happen to a person or even an animal's weight? We would expect it also to go up, so that would be a positive correlation. Time spent exercising, as that increases, what happens to a living thing's weight? Well, that would decrease overall, so that would be a negative correlation. Occasionally students want to argue with this final one about time exercising and weight, but think of it this way. If you have a large population of people, just get an image of what they would look like at a shopping mall. If you put them on treadmills, what's going to happen to weight? We would expect time spent exercising increase. We would see an overall trend that weight would decrease. Now let's look at the given data. It's about fish, and we want to see if there's some sort of relationship between the length of a fish and how fast it swims. And to get a good sense of this is what we do is we graph our data. So we're going to do one by hand, and often you have lots and lots of data when you're looking at scatter plots, and we let technology do it for us, but let's do one by hand. So my x value is my length, my y value is the speed, and I need to number each axis. So I choose to count by 5s on the x, and I selected 20s for the y's because I need to go as high as 148. And now I plot each point as an ordered pair. So 37.8 to the right and up 148 is about here. You might want to pause the video and go through and plot all your ordered pairs. So that's what my scatter plot looks like, and I would say that there appears to be a positive correlation, that as the length of the fish increases, the speed of the fish also increases. We are asked to now draw a line of best fit for this scatter plot and then write an equation of that line. So I just sketched my line of best fit, and you would do this using a ruler. And for you, all you're going to do is really just kind of position that ruler until all the points are about an equal distance from that line. So you have some below and some above, and it seems to be following the path of those points. Then you are going to find the equation of that line. So you have to select 2 points that fall smack on that line. So I'm selecting the point 2070. Notice it is not part of the data set. Another point, it seems like there's a point at about 35, 152, and these are the 2 points I'm going to use to find the equation. So I'm going to use slope-intercept form, which means I need to find my slope and my y-intercept. So on the screen, you'll see in fraction form, my slope is 82 over 15. Then I'm going to select 1 point to just plug into y equals mx plus b. So I'm going to choose the point 2070. So 70 goes in for y, plug in my slope, and the point 20 for x. And I solve this. I'm going to multiply on the right, which gives me 328 over 3. So I have to subtract 328 thirds from both sides, and I'm going to let the calculator do that math for me. And I get 128 or 118 thirds, and that's a negative value for my y-intercept. So the equation of my line is what you see on the screen, and a lot of times we'll express it in decimal format as well when we're doing lines of best fit. So I rounded to the nearest hundredth for my equation. So this is the equation of that line, and we can use that now to make predictions. For instance, if I want to know what I would expect the speed of a fish who is 23 centimeters long to be, what I do is I plug in 23 for my x value. And when I do that, I'm going to do my math here, 5.47 times 23, and then subtract 39.33. I get 86.51 centimeters per second. So that's what I would expect the speed to be. And that point then is falling smack on my line of best fit. So if I went right 23 and up to 86.5, that's about a point right there. Now, our process for drawing our line of best fit was pretty casual. All we did was we just quickly sketched a line that looked pretty good. However, the graphing calculator can do a much better job of positioning that line of best fit and kind of finding what we call the best line of best fit using a process called linear regression. So if you use a graphing calculator and go through this next part of the video with me, you'll see a better line of best fit. So in general, what you're going to end up doing is entering these ordered pairs into list 1 and list 2 in the calculator. So your x values will be in list 1 and your y values in list 2. So on my screen you see a TI-84 graphing calculator, and it's zoomed in so you can see the screen nice and large. Any graphing calculator like a TI-83 will work very similar to this. So to enter your data, select the Stat button. That stands for Statistics, and you want to input your data by selecting Edit or Option 1. So just hit Enter. List 1, L1 and L2 pop up, and I'm going to clear out the data by arrowing up on top of L2 and hitting Clear, Enter, and it wipes out the entire list. I'm going to do the same thing for L1, Clear, Enter. And now I'm going to enter my values. So I just entered my x values. My y values I'm entering now, 148, enter, 47, enter, 88, enter, 131, and 98. One thing that's important is that ordered pairs must be next to each other. So side by side is the x value and then the y value. So I have an equal amount of x's and y's. That's a good sign. So I'm going to go back to the main screen by hitting second quit. So I'm at the main screen, and I need to select linear regression. So I go back into Stat, I arrow over to Calc, so Stat, Calc, and then I select Option 4, linear regression. So I can hit 4, and my calculator, I just have to tell the calculator, yes, this is what I want to do, so I'm just hitting Enter and Enter over again. If you have a different model, yours might be a little bit different. But what you see on the screen is the A value is your slope, and the B value is your y-intercept. So I'm going to round this to the nearest hundredth. So the equation of my line of best fit using linear regression would be y equals 4.74 x minus 21.97, if I'm rounding to the nearest hundredth. So now on my screen you can see the two equations that we got, one when we did it by hand versus the one on the calculator, and the calculator is just doing a little bit of a better job. So it's a great technique to know, and it's something that we use much more often in higher mathematics.